Hi, I'm Kent. Last time I wired up my high voltage system for my kiln. Today I'm going to start working on the low voltage components. In particular, I have a driver board for the K-type thermocouple that I need. And I have some that are MOSFETs. These will be used to drive the relays. These packages are great. It means I don't have to solder like these tiny little components, these surface mount components. And like for this one, it has the resistors already in place. However, they aren't exactly the right form factor for me. So what I want to do is mount them on a piece of perf board. I'm going to place these components on here so they can all be together, and then I can wire these up to the control system. To do that, I first need to remove some of the headers on here because they're not in the places that I need them. That will require some desoldering. I have my soldering iron here, I have some extra solder, and I have some solder wick. What I'll need to do is heat up the solder that's on the board already, and then carefully pull out the components. Either I just lost a bunch of footage of an awesome desoldering job, or I spent several hours struggling with it that you really don't need to see. Here are the boards with the new headers. I replaced the right angle ones with ones going straight down for both the power to drive the relay as well as the power to drive the board. Turn it over, and there are the headers coming down. I also did the same with the board that reads the temperature. So this is what connects to the K-type thermocouple. I'll solder them down and then I'll wire them up so I can connect them to a control board as well as have a place to connect power. One thing to note is I have two boards here to drive the relays. I think having the option to independently turn on the relays and therefore independently turn on the top and bottom elements of the kiln might be useful. The other thing I want to do is make sure all the terminal blocks are facing the right way so I can screw into them. So I just turned them all around. So those are all soldered in now. They won't fall out. So this board doesn't have any diode protection on it. Since I'm going to be driving a relay, which is basically a big inductor, when the power gets turned off, there could be a signal that is sent back and could actually destroy the drive electronics. So I'm going to put a diode in here so that when its power is cut, we won't have that problem. So I need to connect that between the legs of the relay connector. All right, this is a little hard to do on camera, so I've been doing a lot of it off camera. So here I've added the two diodes. This goes between the negative side and the positive side of the solenoid when it's connected up to the terminal block. So here I've connected onto the MOSFET, it goes down and under. And these are the 12-volt positive lines that I've connected up. So I'll be able to wire that someplace as soon as I figure out where I'm going to put power. Next up is probably all of the grounds. I just want to confirm that the ground for the signal and the ground for the 12 volts is the same ground. Yeah, I'm getting half an ohm, so those are connected. You can also look at the back of the other one and see that they're all connected to the ground plane. So it means I don't need to wire both of these up, or I can pick and choose. So ground, ground, and there's a ground over here too. Ooh, hot. Okay, those are connected, now I just need to solder bridge them together. Okay, that wires in. Now I need to jump over to the sensor board. So I'll jump ground to ground. Next, I think I'll do VCC for the three boards. This will be very similar. So jump, jump, jump. Next, I have a signal for this board, a signal for this board, and then 3 for this board. So these ones are just on and off, and this one's I2C. So I need 1, 2, 3, 4, 5. And then I have 12 volts, VCC, and ground. So I have 8. I think I'll connect these to a header so I can attach more easily. Right, so here's a header. Where do I want to put it? I think I'm going to put it over on the edge. There's the header. So I'm going to do power power, VCC ground, and then all the signal lines. Volts VCC. Next we'll do signals for the MOSFETs. Alright, have signal for MOSFET 1 and signal for MOSFET 2. Now we need the 3 lines for the temperature board. I'm running out of color, so I have to reuse some. White goes to the first one, green to the second, and blue to the last. Okay, great. So this should be my low voltage control board. I have the temperature sensor, then I have 2 MOSFETs. I added a diode, and I have power and ground and signal all going here. On the back, I have power moving around to the places I need to, where I couldn't get from the front. Next, I will double check all of these with my multimeter to make sure everything is connected where it should be and there are no shorts. Great, that looks pretty good. Before I connect this to any electrical components, I want to do a quick test. So off to the side here, I have a power supply. It has 12 volts coming in, which will drive the relay, 5 volts, which will control all of the logic signals, and ground. The breadboard here, I wired up a couple of resistors and a few LEDs. So this LED here is just connected to the 12 volt power, showing that it's on. These two here are connected through these wires here to the relay terminals. And then I've connected to the header here, signals. So when these get pulled high individually, they should turn on the LEDs. So the first one I have here is connected to this MOSFET driver, which is connected to this LED. So if I connect it to 5 volts, it'll turn on. So there's an LED here showing that the MOSFET's on, and that turned on the LED. I can disconnect it. This is the other signal line for the other MOSFET. Same thing, I turn it on, the LED back here turns on, and the light, and I can turn both on simultaneously. So right now I'm plugging these in and out. What I really want to do is hook these up to a control board such that they can be turned on and off programmatically. Next, I want to test out the thermocouple. To do that, I connected an Arduino into this, and those are connected to the signal lines of the thermocouple. Thermocouple is then wired up. This isn't the thermocouple for a kiln. It's actually one that came with this control board, but it's still K-type thermocouple. So for testing out, it should work just fine. So I have an Arduino sketch here that's connected up. And this is relatively straightforward. It has some pins to connect to the Arduino. So these are the ones I've connected up. It opens up a serial port. And then I commented out the default print statements, and I'm just printing the thermocouple temperature in Fahrenheit. And then it waits for a second, and it does that again. So on the serial plotter, we can see that the temperature, right now it says it's hovering just above 80 degrees. If I hold on to the thermocouple, so I put some heat into it, it'll start going up in temperature. So this looks like it's working great. So holding on to the thermocouple, it's getting warmer. If I let go again, there'll probably be some hysteresis, and then it'll start dropping back down as the thermocouple cools off. So I think we can use this sketch also to test out the MOSFET boards to control the relays, which are, as it showed before, hooked up to these LEDs. So I think I'm going to do is go through the loop and we'll turn these on and off. So I'll need to pick a couple of different pins to hook up to the control signals. It looks like 10 and 11 might be convenient. Okay, so we're going to count from 0 to 3. So this will go up and then loop back around. If it's 0, they're both off. If the counter is 1, I'll turn on relay A and relay B will still be off. If the counter is 2, relay A will be on and I'll turn on relay B. Next time around, it'll turn them all back off. So every second when it's updating the temperature, it'll also update that. So let's try this out. So here our temperature's dropped back down. So let's see if we can upload this sketch. broken. So I'll turn this off. So for some reason, this MOSFET is not working properly. Good news and bad news. The good news is I did not let any of the magic smoke out. All of the ICs are working just fine. The bad news is these MOSFETs cannot actually be driven by 3-volt logic, which is what this Arduino uses. And the Raspberry Pi I want to use also uses 3 volts. I think I was right on the edge of the tolerance for the MOSFETs since one was turning on and one was not. So a few days later of debugging, I figured out what the problem was. I have a background in technology. I have a PhD in computer science, actually. And I like to pretend that transistors are just on and off. The reality is that they're actually much more complex, and I got stuck in that spot. What I wound up doing was actually getting a few more transistors so I could actually drive the MOSFETs using 3-volt logic. So right now you can see that the LEDs are turning on exactly like we had planned before. Power, and then they're turning on 1, 2, and then both off. This board is now even a little bit more messy. I think it works just fine for now. I'm not exactly happy with it, so I might revisit it at some point in the future, but it should be good enough to get my kiln working. So at this point, I have the thermocouple. I have the MOSFETs being driven by a microcontroller, so I can turn the elements on and off. Next, I'll attach this all to the kiln and make sure it's working there with the actual relays and the thermocouple inside of the kiln. So I've temporarily set all this up on my slip casting bucket. This is by no means complete, and nothing's plugged in besides the temporary power supply down on the floor. So you can hear the relays clicking in the background. I will talk about those in a second. First, I want to test the thermocouple. So it's reading around 81, 82 degrees right now. So if I put my fingers on it, reaching inside the kiln, I can get the temperature to go up. So that's great, it seems to be working. I should be able to measure from one leg of the 240 volt system to the side of the relay, and that's closing or not. So right now it's open. All right, I just closed and I get 0 resistance. The LED also turns on. So this gives me the ability to programmatically control the relays. And obviously I need a permanent mounting solution for all of this. I want to put it on the kiln someplace safe. And I also have a power supply that I will use to swap out in a more permanent configuration. That gets my low voltage and control system in place. I can now read the thermocouple from the kiln, and I can control the relays using a microcontroller. There are still a few things I need to do. I need to double check all the high voltage components, and just as a reminder, if you don't know what you're doing, don't do this yourself. I need to swap out the Arduino. I want to hook up the Raspberry Pi and the control software I found. The other thing I need to do is actually test out the high voltage system. This will involve plugging in the 240 volts for the first time, which will be exciting, and then using the relays to turn on and off the elements under programmatic control using the temperature read by the thermocouple. If you have any questions about any of this, please leave a comment below. I hope you found it interesting. Thanks.